Good morning friends, I welcome you all in this session. As you are aware, in previous session we discussed points related to project time management, and as I said, time management is a very important knowledge area of project management, and in time management area we have seen several processes, right? And there were 7 processes if you remember on that slide, right? So there were 7 processes. Each process had different inputs, different tools and techniques, and different outputs, right? So apart from those 7 processes, we have seen how to monitor a network, right? And there are different ways of monitoring and controlling project, right? So we talked about bar chart or Gantt chart, we have talked about life cycle curves, LOB and network, right? So there are 2 types of network techniques, CPM and PERT. CPM is a technique wherein the duration of the activity is fixed, or it is deterministic or known a priori, right, before you start your activity, while PERT network is a network where you have got probabilistic time estimates. And we have seen how to draw a network, right? So you have got activities, you have got nodes, and you have got dummy activity, right? So let us look at project scheduling terms once again. So you have got successor, you have got predecessor, you have got serial activities, you have got merge activities, burst activities, nodes, and different paths, right? So let's move on to next slide, type of dummy activities, right? So let's look at this network, a very simple network. Activity A or job A, immediate predecessor no. So activity A is the first activity in this project, right? Activity B or job B, its immediate predecessor nothing, right? So activity B is also an activity which is also first activity, similar to activity A, right? If you look at job C, right, this one, job C, right, immediate predecessor is A. So for job C is here, right? Job C is here, right? Our activity C is this one, 3-5 is activity C. Immediate predecessors are A and B, right? Just see A and B, right? Actually this B is connected with C through this dummy activity, right? Similarly, activity E, predecessor is C and D, right? So for activity E, predecessors are C and D, right? So in this way you can prepare a network, and this activity is dummy activity. It's called logical dummy activity, right? So why did we use this dummy activity here? Because we want to know, or we want to connect A and B with D, right? Yeah. If you look at this job D, its immediate predecessors are A and B, right? So this is A and this is B, right? And this is successor activity. So this is nothing but a logical dummy activity, right? Now apart from logical dummy activity, you have got one more type of dummy activity. It's called we use dummy activities for unique representation of parallel activities, right? So apart from logical dummies, one may be faced with a situation where 2 or more activities have identical sets of predecessors and successors, right? So you can have 2 or more activities having identical sets of predecessors and successors. Now what to do in situation like that, right? So in such situation the activities can be done in parallel or concurrently, and their unique identification by referring to node numbers is not possible, right? So you cannot identify those activities through node numbers, right? So what we do, k parallel activities are modeled using k minus 1 dummy activities, right? So these are k minus 1 dummy activities, right? The dummies so inserted are not logical, but perform the function of dummies for unique representation, right? So this is a major difference between logical dummy activity and dummy activity which we use for unique representation, right? So let us look at another use of dummy for creating a single source or single sink in a network, right, which has multiple sources and multiple sinks. So let us say this is your event and these are different dummy activities, right? So you can create multiple sources, right, in as shown in this network, and these are multiple sinks, right? So we can use dummy activity for creating single source or single sink, right? Now I have talked about network representation techniques. There are two techniques, activity on node and activity on arrow, right? Let us look at through some examples. It may be in fact the major difference between these two is that in activity on node type of representation we do not use dummy activities, right? So okay, let us look at this slide. It may be noted that if we use activity on node mode of representation, where each activity is represented by a node, right? So there is no need of adding any dummy activity to represent precedence relationship. Why? Because each activity is getting represented by a node itself, right? So there is no need to have a dummy activity, and this precedence relationship is well taken care by activity on node type of representation. So we are looking at different rules of drawing networks, right? So we have already seen two rules. The first one was, I will show you once again. The first one was, each activity must be represented by one and only one arrow. Second one was, no two activities should have the same initial and same terminal node. This is wrongly written here, right? This is, you just delete this one, right? Okay, so let us look at third point. The arrow based should not form a closed loop, right? In a network you should not have closed loop, right? I will tell you with an example. Let us say there are three activities. Let us say activity A starting here, ending here, activity B. So what we are saying that activity B depends on activity A. So unless and until you complete activity A, you cannot start activity B, right? This is activity B, right? Let us say these are different nodes 1, 2, 3. Now you cannot have a situation like this. Activity C. You can start activity C once you complete activity B, right? Now when you say this, when you say on this activity 3, 1, right? Now what you are saying, activity A you cannot start until you complete activity C. So how it is possible, isn't it? It's not possible at all. So to avoid a situation like this, you need to introduce dummy activities, right? So this is closed loop or consistency in project network. There should not be any closed loop and there should be consistency in the project, right. So you got activity A, B and C, right. So how to find out closed loop in a network? Very difficult task. In a small network like this, you can easily identify whether closed loop is there or not. But let us say in a large network you have got, let us say hundreds of activities and let us say hundreds of nodes, right. So you cannot easily identify a closed loop, right. As far as this particular node is concerned, you can identify a closed loop. Is it possible for you? Just look at this network carefully. Can you identify closed loop? Is it there? Yes, I think there is a closed loop, right. And the closed loop is like this. Let us say yeah, this 4 to 5, 5 to 2 and 2 to 4, right. So this is a closed loop, right. So because since this is quite a small network, you could easily identify closed loop, but in a large network you need to have some scientific method of identifying closed loop, right. So let us look at what is that method, right. So first of all, you should prepare an adjacency matrix, right. So this is your matrix which you have prepared from this particular network, right. So in this network, if you look at, there are 5 nodes, right. So 1, 2, 3, 4 and 5, right. This 1, 2, 3, 4, 4 and 5, right. So let us find out how these nodes are connected, or what is the relationship between these nodes, right. So from node I to node j, right. So let us say 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5, right. So is there any connection between node 1 and 2 here, or let us say first 1 and 2, right. 1 and 2, yeah, there is no connection. So 1 to 2, 0, right. 1 1, 2 2, 3 3, 4 4, 5 5 will always be 0, right. So is there any connection between 1 and 2? No, there is no connection, right. Is there any connection between node 1 and node 3? Yes, there is a connection, this one. Is there any connection between 1 and 4? No connection. 1 and 5? No connection. Similarly, is there any connection between 5 and 2? Yeah, there is a connection, right. Isn't it? Is there any connection between 5, 3, 4 and 5? No, there is no connection. So first of all, prepare adjacency matrix like this. The next step is take square of this matrix, right, or find out m square value. You just multiply this 5 by 5 matrix with the same matrix, right. So you will get m square, right. So this matrix is nothing but m square matrix, right. So you have got all 5 nodes here and all these 5 nodes here, right. So when you multiply m with m, you will get m square, right. Just see this. So if you look at m square matrix, m square has all zeros on diagonal, right. There is no one value in all these diagonal cells, right. Since there is no one value here in these diagonal cells, will calculate m cube, right. So the next matrix is m cube. So m square you are already having multiplied with by m, right. You will get m cube, right. So if you look at m cube matrix, yeah, if you look at this diagonal cell, there is value 1, here 0, here it is 1, here it is 1. So what do you infer from m cube? So if you look at m cube, the appearance of 1, right, to diagonal elements of nodes 2, 4 and 5, right. 2, 4 and 5 indicates the presence of loop in that particular network, right, or in other words we will say this network is inconsistent, right. So, what is the loop? Loop is 2, 4 and 5. How did we come to know this? Because there is a unity value or value 1 across diagonal cells, right. So, this is how you can identify whether a network is consistent or inconsistent, right. If there is a loop, it would be called inconsistent, right, otherwise consistent, right. So, a better method to identify closed loop in large networks, right. So, let us find out how to draw a network, right. So, let us take first example, and the problem statement is like this: A precedes B and C. Now, you can rewrite the same point like B and C follow A, right. So, when I say A precedes B and C, it means A is the predecessor activity and B and C are successor activities, right. Or I can also say B and C follow A. So, A is the predecessor activity and B and C are successor activities, or I can also say B and C depend on A, right. So, first you need to complete activity A and then B and C would start, right. So, you can have different types of representation, right. So, either you say A precedes B and C, or B and C follow A, or B and C depend on A, one and the same thing, right. D follows B, right. So, in this network if you look at A precedes B and C, right, A precedes B and C, D follows B, right, D is following B, right. So, B is predecessor activity, D is successor activity, right. E follows C, yes, just see this, E is following C, right. D and E are terminal activities, just see activity D, activity E are terminal activities. So, in this way you can draw a network, because if you do not draw a network you cannot calculate the exact duration of the project and different other parameters of the project. Let us look at this particular example, right. So, what is the example? A and B start immediately. So, you just start activity A and B, you just start preparing, you just take a pen and pencil, pen and notebook and start preparing network, right. So, A and B start simultaneously, C follows both A and B, just draw a network. So, A and B starting, so you just take A and B and C is following A and B, right. So, C, just draw activity C, D follows A, right. So, after A there would be D activity and E follows D. So, after activity D there would be activity E. The project is completed when C and E are done, right. So, let us see how this network looks like. Just compare your network and my network. This is the answer, right. A and B start immediately, right. So, they are starting simultaneously, right. C follows both A and B, just see, this is C which is following A and B, right. Since you cannot have a network from here to here and here to here, because if you draw that, that would be a violation of a rule, right. So, you should use a dummy activity here, right. Then D follows A, yes, activity D is following A, right. E follows D, yes, activity E is following D, right. The project is complete when C and E are done, right. So, with C and E are done, project is complete. right. So, this is example 2. Let us look at third example on how to draw a network. A starts immediately, right. So, the first activity is A. B, C and D follow A. You need to draw network very carefully. So, B, C and D follow A, right. E follows B, C and D. So, just draw this network. I hope that you would have drawn a network for this example, right. Let us compare your answer with my answer, right. And let me tell you, it's not necessary that my answer matches with your answer, right. You may have a different way of representing a network. I may have different way of drawing a network, right. So, you may use 2 dummies. In my network I may use 1 dummy activity, right. So, try to minimize use of dummy activities in a network, right. So, this is how you can draw, right. So, A starts immediately, this B, C, D follow A, right, activity B, C and D, right. In fact, if you wish, you can enter your node numbers also. I will tell you how to number these nodes. Then E follows B, C, D, right, activity E is following B, C, D, right, but you have used 3 dummy activities D1, D2 and D3, right. So, this is one way of representing network, right. You could have used another method, right, or another way of representing the same network, right. So, this was our first answer, right, for this particular question, right. You could have done this also, right. So, A starts immediately, B, C and D follow A, E follows B, C and D, right, E is following B, C and D. So, in this way I have reduced one dummy activity, right. So, I would say this one is a better network, right. Let us look at some more example. Yeah, the fourth point is the arrows representing activity should be straight, not curved. Try to use straight arrows whenever you draw any network. Let us say A, B and C start immediately. So, A, B, yeah. So, this is actually A, this is B and this C, right. It is up to you. You could have used this as A, B and C, not a problem, right. E follows B and D. E follows B and D, right. So, this is activity B, this is activity D, right, and E is following them. C and D are terminal activities. C and E, just see, this is activity C, this is activity E, are terminal activities, right, are the last 2 activities, right, terminating at this particular node, right. But you have used this curved arrow, right. Do not use curved arrows in network, right. So, how to avoid a situation like this? Can you draw a network where you do not have this curved arrow? I hope you would have drawn a correct network, right. Let us see this. This is a correct network, right. So, A, B and C, this is D and E, right. So, this is a better network, right. Try to use straight arrows, not curved arrows, right. Avoid crossover of activities whenever possible, right. Just look at this. in this network activity D and C are crossing each other, right. So, try to avoid a situation like this, right. If not possible, then you can you can have a situation like this. For example, right, let us say if you have a network like this, right. So, rather than having a situation like this, you can do one thing, just use this symbol, right. You can do this kind of you can write, you can convert just cross section into this type of situation, right. If possible, try to avoid, if you don't, if you are not able to avoid, then you can have a situation like this, right. Now, there are a couple of examples on how to construct a network. Let us look at this example. A and B are the first activities of the project, start simultaneously, right. So, there is one node, A and B are starting simultaneously. A precedes C and F, right. So, C and F are following activities of A, right. In other words, C and F follow activity A. B precedes D and E, right. So, D and R, in other words, D and E follow B. F and D precede G and H, right. So, first you have got F and D, and then you have got G and H, right. C and G precede I. E, H and I are terminal activities. So, all these activities are coming at one particular node, it is called sync node, right. So, just try to draw this particular network. Yeah, I hope you would have drawn this network. Let us see whether it's right or wrong. Yeah, this is the one. So, A and B are the first activities. As I said, there would be one node. We can call these two as burst activities, right. So, from one node you are having multiple activities coming out of it, right. So, A and B are first activities. A precedes C and F, right. Yeah, A precedes C and F, right, C and F. B precedes D and E, right. So, D and E, right. F and D precede G and I, right. F and D, right. F and D are the previous activities, and G and H are successor activities, right. C and G precede I, right. This C and G are preceding I. E, H and I are terminal activities, right. This is also known as sync node, right. So, E, H and I. So, this is how you can construct a network, right. So, this is an example, just try to construct a network for this example. So, you have got different activities. So, activity A, and it does not depend on any other activities, right. Activity B, right, depends on activity A. Activity C depends on activity A, D depends on activity A, and so on, right. If you look at this one, activity K depends on these two activities I and J. Activity L depends on three activities F, G and H. Last activity N depends on L and M. So, just try to draw a network. I hope you would be able to draw a network. Let us see how it looks like. So, I have drawn this network here itself, right. So, activity A, activity B depends on A, right. So, activity B depends on A. C, of course, this is activity C, is again depending on A. Activity D again depending upon A, right. So, B, C, D, all these 3 activities depend on A, right, and similarly you can see other activities. Let us look at this one, right. Activity K depends on I and J. So, this activity K is depending upon I and J. So, unless and until you complete I and J, you cannot start activity K, right, which you can see in this network, right. What about this? Activity L depends on F, G and H. Activity L is depending upon F, G and H, right. So, this is F, this is G and this is H, right. It means we have drawn a correct network, right. Similarly, this is the last activity which is N, right. So, you just do practice on how to draw networks, and there are several books available on project management. Towards the end of this particular subject, in last session I will give you all the references which I have been using in this particular course, right. So, let us look at some more points related to activity on arrow and activity on node based network. So, let us say you are moving from your old house to new house, right, and in doing this you need to perform several activities. So, you need to look at several houses, right, you need to review houses, then finalize your requirements, engage architect if needed, evaluate alternate designs. So, you will have different houses having different designs, right, finalize contractor, foundation, then brick work, RCC work, plumbing will be there, wooden work will be there, organize party, housewarming party, shift luggage and settling in new house, right. So, let us say these are couple of activities of a project when you are shifting from old house to your new house, right. So, you can prepare a precedence relationship, right. So, these are different activities, right, A, B, C, D, and I have written what these activities are, right. So, first you just draw a precedence relationship network. So, this is activity on arrow network, right. So, A and B. So, A is reviewing house and you are simultaneously finalizing requirements, right. Activity C, engage architect, then D, E and so on, right. Finally, settling in new house, right. So, this is activity on arrow type of network, wherein this is your dummy activity, right. You can prepare a network diagram for this example using activity on node type of network representation technique, and we have seen couple of examples on activity on node type of networks, right. So, you will have a similar network without dummy activity, right. So, let us look at, we will take the same example. Here what is the difference between these two? Here activities are represented on nodes and the arrows represent the precedence relationship, right. So, this is the major difference between activity on node and activity on arrow. Let us look at solution to this question. Just see, this is activity on node. So, we have represented all the activities of this question on nodes, right. So, these are different nodes. So, activity on node this, activity on node this and so on, right. This does not have any dummy activity, right. So, this is another example on activity on arrow, this is activity on node, right. So, we have seen couple of examples on activity on arrow and activity on node. Now, in a network you should have different types of representation. How do you label a network? Because in a network you have got different nodes and different activities. In the next class I will talk about how to label different nodes and activities and durations and resource requirement on a network, right. So, we will see this particular point in next session. So, with this, thank you very much. In next class we will start how to number different nodes and some more points in details. Thank you very much.